Setting tab. In this tab, it is possible to manage some settings related to running the tests. In Supply Direction section, it is possible to determine the direction of injection and fold at the two sides of the protective device for the test. To better understand this, open Vector View. Here you can see that if Fault Primary Supply Secondary is selected, 3 primary currents of the transformer are displayed in Vector View, while by selecting Fault Secondary Supply Primary, 3 secondary currents of the transformer are displayed. Note that for inrush blocking tests, 3 primary currents need to be injected. In Fault Inception section, the angle where the fault occurs is specified that this angle shifts currents of the both sides equally. To better understand this, select Signal View from the toolbar and check Voltage Group A from Setting, and by changing the value of angle, view the voltage and current signal changes. If for any reason you wish to enable the voltages, you can do so by checking Enable Voltage Output from Voltage Output section, and then you can enter the value of the voltage in the intended field. In Coefficient for Fault section, it is possible to specify a coefficient for fault current values. For single phase factor and for 3-phase factor fields are the fault current coefficient for single phase and 3-phase faults. By changing the fault current coefficients, it is possible to view the changes in Vector View. In Time section first, the injection time before the fault is entered in pre-fault time. In Maximum Fault Time, the maximum fault injection time is specified in 2 forms of absolute or relative, which consist of 3 parts themselves. About this time, note that if in a shot point the maximum fault time is shorter than pickup time, the result of the evaluation will be wrong. If you are using the maximum fault time absolute field, you need to enter a time in terms of seconds for the maximum fault signal injection time, but to accelerate the test, you can use the maximum fault time relative option. By checking this option, 3 other options appear. By entering a number in add percentage of t-nom, the fault signal injection time in any point equals the test point nominal time plus a percentage of the nominal time entered in this field. This means that if the test point nominal time is 10 seconds and 5% is entered in this field, the maximum fault injection time is 105% of the test nominal time, which is 10.5 seconds. But in add absolute field, the fault injection time equals the sum of the nominal time of the test point trip plus the time entered in this field. If all these 3 fields are filled, the software picks the longest time entered. For points that are located at the no trip zone, it is possible to enter a separate time in no trip time field. In post time field, the injection time after the fault is entered. Delay after trigger is used to enter the key trigger time. By right-clicking on the related field and selecting Go to Linked Value, you can see that it is linked to CB trip time, and if necessary, you can replace it with your desired value by selecting Remove Link. In Time Reference, by selecting Fault Inception, the trip time is calculated from when the fault is injected. But by selecting Starting, the trip is calculated from when the pickup contact is received from the relay. In Load Current section, you can specify the settings for the phase and current related to pre-fault. In Amplitude section, by selecting Based on Current radio button, the pre-fault current is entered in terms of ampere, which is the same for all test points. But by selecting Based on I-fault, the pre-fault current is entered according to the fault current, which is different for every shot point. Also, the angle of the current in pre-fault mode is entered in Phase section. In Surge Settings section, the settings related to surge tests are specified. As mentioned before, a surge test arrives at a conclusion only if one of the 3 conditions of this section is met. The first condition is relative, which means that if the difference between the test point value and the previous point is less than the percentages specified in this field, this very point is the result of the test. The second condition is absolute, which means that if the difference between the test point and the previous point is less than the value specified in this field, this very point is the result of the test. The third condition is maximum point number, which means that the test is to be performed as many times as the number of points entered in this field at maximum, and the last point is the result of the test. But if for any reason the relay nominal characteristic is not available, you can use Ignore Nominal Characteristic section. By doing so, the software ignores the existing characteristic. Then, based on the step entered in search interval, it adds shots on the search line. For example, a line is drawn in search test section. Then 0.5 is entered as the value for search interval and apply to all is selected. You can see that some points with the same step are added on the search line. By running the test, you can see that the test starts from the lowest point, and once one of the three mentioned conditions is met, the test arrives at a result. Also, if necessary, you can ignore this option by selecting Disable All. By selecting Shot Passed Only Act in Main Zone, in other settings section, the test is passed only if the relay performance time in the shot point is somewhere in the allowed range of the main zone. This means that if this option is checked and a shot is added in the tolerance zone of the bottom of the characteristic curve and the relay does not give a trip, the test passes, but if the relay gives a trip, the test fails. If the shot passed only act in main zone option is not checked, the performance time is between 20 milliseconds and no trip, and if the relay gives a trip, this point passes. Search passed only act in zone is for search test, and by checking this option, the search test is passed only if the relay trip is in the tripping zone of the nominal characteristic curve of the relay. In pass settings section, by checking pass if get any trip option, regardless of the relay performance time, if the relay operates in the tripping zone, the test passes. In Trigger tab, you can specify the desired binary to receive the pickup and trip signals of the relay as well as stopping the current injection. The settings and explanation of this section are exactly the same as mentioned for Trigger Room and Sequencer. In Binary Output tab, if it is necessary for the relay to view the conditions of circuit breaker, it is possible to take any needed voltage to the binary input through binary output of the device by voltages of A, B, or auxiliary DC groups. This tab has three modes of pre-fault, fault, and post-fault, and it is possible to manage each of them separately.